Ready. Ready. Ready.
Hello, welcome to Enlightning. Today is our third episode in the series on Service Mesh. It's about Istio, and we're here with Marino, who's going to teach us. Marino, tell us why we should trust you to teach us about Istio.
Hey, Whitney. Hey, everyone. Thank you so much for having me here. I'll be honest. I've been waiting a while for you to reach out to me and say, hey, can you be on my episode? And the moment you reached out, I was like, yes, oh my God, I was jumping all over the place. Anyways, my name is Marino Wijay. I am a principal developer advocate at Solo. Solo is an application networking company focused on service mesh, API gateway management, and even CNI now. So it's really covering a bunch of networking technologies in that OSI model is what I like to refer to. Now, why y'all should trust me? I've spent a good chunk of my life and career in the networking space, and seeing what has transpired in cloud native networking has just excited me all over again. So I wanted to jump back into it and see what was going on. I wanted to dive deep into things like service mesh and container networking and proxies and API management to really understand how a lot of that networking has transformed. So I spent a good maybe 4 years really diving into this stuff. And, I'm here to just share whatever I possibly can with y'all. And I think we've got to keep that time. Yeah.
Thanks. We did a series on Ingressi, I don't know, and then Service Mesh. Service meshes, we're in the midst of that. So a lot of the words you just threw around are words that are relatively new to me. I'd say within the last 6 months at least, like an API gateway. It's very similar to an Ingress implementation, maybe with a little bit of extra added feature. The OSI model, is that what it is? I forget that
Open Systems Interconnect model.
With all the different networking layers. And then what you said, CNI, we did a Kubernetes networking episode with Duffy. So some of these, I've been struggling on the show with how much knowledge can I assume people already have? Because we're starting to get into some pretty deep stuff. And so we should say cloud networking. What's CNI stand for? Interface.
Yeah,
cloud
container
networking interface. But if you, as those of you watching, if there's something that if we assume any amount of knowledge, if it's been on a past show, I might let it slide. But if you want to know what it is in the moment, please speak up. We're very happy to back up and talk about what it is. And then we have so many people saying hi in chats. I want to say hi back to you. Hello, Code with Sean. So good to see you. Hello, Epic Tralala. So glad you're here. Rats. Thanks for coming to Enlightning. Thank you.
Hey, Archie.
Yay, Bucky Buck. Hello. And Tiffany's here too. Hi, Tiffany. Awesome. I feel so much love right now. So those of you in chat and Marino, who's going to KubeCon or who's going to watch virtually? Anybody? What are you excited about? You? I'll be there.
I'll be there all week long. So I get in Saturday for the Rejects conference. And it's a fantastic conference, B-side conference, where folks that didn't get accepted into KubeCon, great place to submit to. And quite honestly, I feel like the best talks end up there. And I feel like it's such an immersive, intimate experience. So you go check that out right before KubeCon. And then you've got the Colo Days. So I'm presenting it too. I've got Edge Day, where I'm going to be talking about doing, I think it's ambient mesh at using a Raspberry Pi, actually. It's kind of interesting. I'm
cool.
working with one of my engineers, and we're like just developing this little demo to make this all work. I've even got a Pi somewhere back there. And then my second session, I'm diving into some networking stuff with the Cilium CNI. So Cilium actually is a little near and dear to me in terms of the networking stuff it does, only because of my networking career. Actually, before I really got into cloud native, when I was working at VMware, by the way, I did work at VMware, so I spent about 5 years there. So it's nice to kind of revisit a lot of the, anyways. When I was there, I heard about the Cilium CNI, and I started attending some of those Echo episodes where Liz Rice was on and walking us through what Cilium is and how eBPF, a really interesting function of the kernel, was helping with optimizing networking inside of a container environment. So I initially attended some of those videos, and I just fell off because I had so many other things going on in my life. But I realized how quickly the technology itself was growing. But that was the hook, right? Like that was the hook. It was a bait. It got me into the cloud native, and now I'm here talking about Istio and Service Mesh. And so it's interesting to see how a lot of this has come full circle. But I won't be doing anything specifically at KubeCon other than just hanging out and hoping to run into folks and chat with y'all during the hallway track session.
High-fiving everyone. You mentioned Cilium. Cilium, we're going to do an episode on Cilium next with Duffy Cooley on November 2nd. I haven't made the webpage for that yet. And then we have folks who are definitely going to be at KubeCon who are watching. You said Archie, right? Archie's going to be there. Arat's going to be there. Tiffany said that she'll be there too. Rejects, I love. It's called, the full name is Cloud Native Rejects. And I just love that the community is leaning into the fact that a lot of great talks can't get into KubeCon. Like there's something like 5%, I think 5 to 8% of talks that get submitted get actually accepted to be given. So honestly, most of us are rejects in some way or another. So let's just lean into it and make a cool conference with what's left. What I like about Rejects too is it's before KubeCon starts, and everyone is like bright and shiny and bright-eyed and bushy-tailed. Like we're just arriving and so excited to be there and see each other. If you find us later in the week, we're like tired and a little bit dead inside.
Yeah, I'll be hiding in my hotel room, just dodging everyone's DMs. And I'm sorry, but I need to recharge.
So if you want some fresh folks, we're all fresh at Rejects. Let's start maybe moving our way behind the light board. What I would love to hear from those of you watching, like what are you hoping, what questions do you have about Istio and Service Mesh in general? Are you currently using Service Mesh? If so, what are you using? Ask some questions for us right now. Give us some context about where you're at. And then meanwhile, Marino, I've had a theory. I think you are so prolific. Somehow you managed to be everywhere, even at the overseas conferences. And you managed to put so many resources out in the world that I think that you're like one of a set of triplets. And I just don't understand how you do it all. But instead of telling us the secret of how you do it all, will you tell us about all that you do?
Yeah, there's a number of different things that I've been working on over the last, I'd say, several months. Earlier this year, I started a project called 70 Days of Service Mesh, open source, dive into Service Mesh from the lens of Istio, but in bite-sized chunks. I will be very honest, I am not done. I think I'm still at day 11, and I've got like maybe just about 70 days left in the year. So I better get cracking. I mean, if I can push another 10 days and I still got 2 months left and I should be okay. That being said, it's a great project if you want to understand a lot of the fundamentals of Service Mesh. But not only that, there are it assumes that you know certain things. There's certain things that you have to know in a mesh. You have to know some of the basics of networking to truly understand how a mesh functions and what goes on inside of that mesh, how services communicate. So I even shim in some networking basics in there, understand and help you all understand like how the Kubernetes basics ties into some of the mesh stuff as well. Another thing that I've been working on actually with one of my colleagues, actually two of them. So the Istio certification, it's a certification exam, much like the CKA. It was launched probably about a month ago.
Who's
And
the
go ahead.
certifying body for that? Is that the Linux Foundation?
Yeah, it's Linux Foundation. So very
Okay.
much like how they provide oversight for the CKA, CKAD, and some other exams. They're
Okay.
doing the same thing for the Istio cert.
I
So
have another question.
yeah,
Do
yeah.
they do it for all of the graduated projects?
I don't think so. I think it's just
Okay.
really on it's on the project to come out and say, hey, we want to build a certification. And
Okay.
to a degree, it's a bit of a marketing tool, right? The marketing
Uh-huh.
tool aspect of it is you're driving folks to help them level up their careers, but simultaneously building advocates that know your technology very well. And quite honestly, it's a good thing to know how a service mesh works because it actually exposes you to how a number of other things function inside of a microservices environment, especially a highly distributed one.
Uh-huh.
But having said that, right, there's been a massive amount of community-led training that has been developed for a lot of these different certifications over the years. And it's phenomenal. Like people are going well beyond what an official training class would teach you to give you all the necessary pieces to succeed. So having said that, right, with that certification that came out a few weeks ago, I live streamed with a couple of others to like dig into service mesh basics and map it to the Istio certification as well. So it's all hands-on. You all should go check it out. And then the final thing is like go check out Solo Academy if you really want to get deep into Istio and service mesh. We've got tons of self-paced, self-led workshops, and we also do live ones as well, like webinar-based ones.
Excellent. We have a question for you, and we'll learn some context here. Akil says, I'm starting to learn the Istio Service Mesh. Should I start with a sidecar model or ambient mesh? Maybe first, some of this I think I want to capture on the board, but maybe first we'll casually say what the difference between the two is before answering.
Yeah, the real main difference between the two is just more of an operational model. And it's really to align with your technical and business needs. At a high level, it's still service mesh, it's still Istio. It's just a flavor where no sidecars are deployed, but mesh functionality is still available. We'll get into details as we're covering more.
Okay. And for someone who's just getting started, which model do you recommend?
So if you're just getting started, you're going to learn the sidecar model regardless, because there will be situations where environments are using a sidecar model, environments are using a sidecarless model, and environments are using both. And everything started with the sidecar model anyways. So it helps knowing how to use the sidecar model alongside your main container, and understand the functions it provides, how it executes and terminates things like mutual TLS, and where that shifts off to when ambient mesh enters the chat. So you should still start learning the sidecar model. You'll additionally learn ambient mesh, a sidecarless model, as a result of it too.
Cool. We have someone new here, Alessandro. I have to confess, before we started this series, so less than a month ago, I say we, before I started this series, I didn't know there was such a thing as a sidecar-less model. The only service mesh I'd been exposed to was sidecar. And sidecars, when you have in Kubernetes, when you have a service mesh container running alongside your application container in a pod. So we've done an episode on Linkerd. Last week we did an episode on Kuma, and I've asked both those projects to define what service mesh is. So I would like to hear your definition of what is service mesh, and I'd also like to hear why Istio came to exist. Like, what problem was Istio solving when it got made? When did it get made? Tell us, so give us some
Yeah.
context.
Yeah, absolutely. So a service mesh is a framework and a platform where microservices have the ability to discover each other, connect to each other, but also provide authentication mechanisms and authorization mechanisms. So there is trust and identity built into every single communication stream.
It's a framework and a platform. That's as far as I kind of listened past that, but my
Okay.
brain got a little bit stuck there because I'm like, what does it mean to be a framework? What does it mean to be a platform? We dig
Yeah.
into why you chose those words. Yeah.
So the platform offers up something pluggable where things can connect in anything. It could be a microservice, it could be a function, it could be something that we need to help move things along. Now, the framework aspect of it is there are a set of principles that we want to align to create resilient microservices. And so Service Mesh offers up that framework, and it actually maps
Okay.
to 3 pillars. We'll talk about that when you're ready.
Okay. So it's a framework and a platform that offers what?
So the framework itself offers the pillars of observability, security, and connectivity. The platform is the specific implementation of those specific pillars.
So security, observability,
And connectivity or
and
traffic
connectivity.
management.
I like connectivity. This is consistent with what the others said. And those are the framework. And then what's the second half? Get that one more time.
So you've got a service mesh as a framework and a platform that offers security, observability, and connectivity for a variety of different kinds of workloads.
Okay. Cool.
I love your writing. It's just like so perfect to me. And it's like because I feel like you're writing backwards, but I don't know how you're writing so perfectly. I'm gonna need to have a magic on this thing.
Just yeah, it's just lifting the camera. I don't get too much credit for that. But it is lucky that I have good handwriting. I think this might be a poor career choice for me if I didn't. So I love this. So I understand it. Linkerd said that they were the first service mesh. So when Istio came onto the scene, service mesh already existed. What was Linkerd? I don't want to like say I'm not expressing opinion that anything's better than anything else. Like I think everything has its own use case and is good for what it's good for. I don't think this isn't a competition. But the question is like service mesh already existed and someone in the world was like, hey, we need to make a new one called Istio. And so why? What was missing in the landscape at that time?
So some of this has to do with the way some organizations that champion the idea of service mesh consumed it and built it. So there's this proxy called the Envoy proxy, which effectively it's a reverse proxy which handles connections. It can allow you to enforce policy. It can allow you to provide an observability point and other capabilities that can be highly customized. So with this proxy, go ahead. So with this proxy, you could land it pretty much anywhere you wanted to, and it would do the work on behalf of a workload or an application. But if you have scale, if you have like 10 plus different services that exist in your environment, and they all needed their own little proxy, well, someone has to sit there and build a control plane and even find a way to allow these proxies to communicate amongst each other. So a data plane. Now, when you think about Linkerd, actually Linkerd had this model initially, Linkerd version 1, where they deployed a gateway style model where all your resources would work through and flow through a gateway that lived at the edge of your cluster. And they evolved to go through a sidecar model. They built their own proxy, and Envoy was an open source proxy that could be highly customized. So you have companies deciding, how do we really take advantage of this very high powered proxy but also automate it and then make it available to workloads in a very simplistic manner. And that's how Istio was born. Now, there was some work that went in back in 2017 to spark this idea where you can use Envoy, but through a control plane that would abstract how you would configure Envoy. And this was primarily because Envoy itself is very complex to configure. You're actually having to manually build something called filters, which if you have a variety of style of applications, and then you also have some that are doing the same thing, it's very difficult to manage all of these filters and build them out and then chain them together. So Istio solved this particular problem where it would simplify how you would configure Envoy, but you wouldn't have to directly configure it.
Istio simplifies the process of configuring Envoy.
Exactly. It's an abstraction layer.
Cool. Great. So on what I understand, we talked about Envoy before in Ingress episodes in addition to past Service Mesh episodes.
Mm-hmm.
So what I understand of Envoy is that it's wildly powerful, but also wildly complex to the point where there's a Envoy gateway project where a standardization of how to configure Envoy, and that like no regular user, no human should be configuring it directly. It's too complex for even that.
Well, for the majority of use cases, yeah. But there are corner cases where Istio specifically can't address a particular configuration, and so you need to customize Envoy for those corner cases.
I have a question, and then we also had a great question come up in chat. So we said Istio is a sidecar. Is Envoy running as a sidecar?
Envoy actually is the sidecar.
Envoy is the sidecar, and Istio is a control plane to help you configure and control all the Envoy sidecars.
Absolutely.
Cool. Yes. And then we have a great question from chat. I love this. Are Istio and Service Mesh the same? So Istio is a type of Service Mesh, and Service Mesh used to be a sidecar model. That's how it was, but now it can be other things too. So it's more of it's a way to provide security, observability, and connectivity through everything that's running in your Kubernetes cluster, but also you can use it in other systems too. So it doesn't have to be Kubernetes. So on Enlightning here, we're doing a whole series on all the CNCF Service Mesh projects. And so we've already talked about Linkerd and Kuma. Today we're doing Istio, and then we're also going to do Cilium. And then I hear there's one called Iraqi Mesh that I still need to look into. But those are the different types. And then this one I want you to answer, Marino. What's the difference between a load balancer and Istio?
So Istio itself is a full system that provides the capability to configure load balancing. A load balancer itself is just it's an artifact. It's an actual appliance that functions as such. It basically will balance your loads or your requests. So, for example, I have 2 copies of the same application, and I am trying to provide high availability for that application. So I would front end it with a load balancer. And if one of those copies fails, well, because the traffic has to traverse that load balancer, it's going to know of that failure and will still direct the traffic towards the surviving copy. Now, you would have to configure this directly at the load balancer level, whereas Istio allows you to leverage labels and Kubernetes primitives to set up that load balancing using Istio primitives. So it's more of a Istio allows you to provide the logic for how you would want to configure load balancing, but the load balancer itself is the appliance that actions those instructions and that logic.
So load balancing is one of the things that Istio can do, but Istio can do a lot of other stuff in addition to load balancing. Yeah.
Exactly. So
Cool.
do you want to dig into those capabilities?
I think I do, and maybe this is all the same thing, but I have like what is service mesh? I have why Istio was created. I can maybe infer what Istio is then. Istio is a service mesh that uses Envoy
Yes.
as a proxy. But
Yes.
is that how you want to define Istio here? I'm
Yeah,
gonna
I think that's a
yeah.
good solid definition of what
Okay.
Istio is. And it pretty much aligns with what a true definition of a service mesh is.
Okay. Great. So I'm gonna write that down and then we'll dig into all the different things Istio can do.
For sure. And I believe there is another question as well.
Oh yeah, bring it.
All right.
Did I?
So Indrajit said, is Istio compared with API Gateway? So yes, actually, there is quite honestly and commonly a comparison between the two. So the API Gateway functionality has been around for a long time. In fact, it's still widely used, and it's what I consider to be the front door to all APIs. But having said that, if you were to take an API gateway and stick it in front of every service, what you're effectively creating is a service mesh-like functionality. So Istio, while it does provide the facility to offer up API gateway functionality, there's still some additional bits and pieces that have to go in inside of a let's say the ingress gateway that Istio has, and those aren't default configurations or default settings. So, for example, an API gateway provides rate limiting. Why would you use rate limiting? You don't want to overload a service and make it unavailable. Now, in order for that to be enabled with Istio, you'd have to tune Envoy to rate limit appropriately on the right requests and based off of attributes. But something needs to watch that and enforce it. And so you need to pair Istio with a rate limiter service or server or something of that nature. So it tells Envoy to block a request or reject a request per a number of requests that come in. There's another another question here.
Excellent.
But the load balancing is done by regular services in Kubernetes, or Istio have that capability. So yes, Kubernetes does load balancing to multiple copies of a service, right? So if you have a deployment and you define three replicas, which create 3 pods for that particular deployment, and then you have a service attachment there that has a label that will look for any pod that has that label associated to it, then it'll effectively forward that request over in a round robin sense. But here's the thing, sometimes you might want to load balance across different clusters. And that's something Kubernetes can't natively do today. So you might have to involve something like Istio. Sometimes you might want to load balance between different versions of the same application. And so it's a little bit more challenging to do within Kubernetes, but it's much more easier with the way Istio handles it. We'll talk a little bit more about that as we dig in.
One thing that was confusing for me when I first started getting in the space, maybe it honestly still is a little confusing for me, is like we have this family of ingress technologies that help traffic get into the cluster in the first place, and then service mesh that helps traffic move around once it's in the cluster. But it seems to be like a lot of overlap too, especially with y'all service mesh saying, oh yeah, we can do an ingress too. We have an ingress implementation in addition to our service mesh. So yeah, that just adds another level of confusion. An API gateway is kind of the same thing as an ingress implementation, but not quite.
Yeah, so ingress is a mechanism to help route external requests to the right resource. And when it comes down to it, something needs to be able to perform that action. So an API gateway can perform that action. You can even configure Envoy on its own to perform the same kind of action for ingress. But you're basically saying, I'm going to create an ingress resource, and Kubernetes now needs to look for a controller of some sorts to be able to action that resource. Now, if you take Istio offers up something called the Ingress Gateway, which offers up Ingress capabilities. So if you decided, hey, I'm going to stand up a Kubernetes native Ingress CR or a custom resource, Istio will know and understand how to process that. However,
is that a custom resource? The
yes.
Ingress Gateway? Okay.
Yeah. So it's a custom resource. Well, it's a Kubernetes custom resource, which Istio would understand. But you would normally affix an annotation to tell Kubernetes use Istio to do your ingress for you. That's one way, but it's very limited in capability and features. So we prefer you use the Istio Ingress Gateway and the Istio Ingress Gateway resource itself. And it's a different resource because it's not Kubernetes native, it's Istio native, which Kubernetes still can understand.
Which is a total normal pattern. Like Contour Ingress has their own custom resources. Emissary Ingress has their own custom resources. And now there's Gateway API, which is a standardization about how to define your own custom resources within to be able to configure networky things, largely Ingress. But yes.
Yeah, basically Gateway API is going to be, or is basically the replacement for Ingress or the Ingress capability in Kubernetes. And it does basically the same thing, but also some more capabilities as well, which allows you to define classes and structure it from a role-based access control standpoint. So the primitives are still roughly the same. It's just now you have vendors who offered up Ingress capabilities will now conform to the Gateway API spec. So everyone would configure it the same way. You just specify a gateway class based off of who's going to offer up the Ingress capabilities. And Istio would in this case.
Excellent. And we have this one is maybe a little off topic. In Kubernetes, can we use a replica set for high availability?
So a replica set is actually a function that sits right below a deployment. And all it really aims to do is ensure that you're running the desired number of copies that you've told Kubernetes to run. So if I say I want to run 5 copies and I've specified in the deployment as such, the replica set, which gets created per the deployment, actually will be responsible for ensuring 5 copies of that app.
And so if you want that to scale, you would want to use natively in Kubernetes, a horizontal pod autoscaler. But if you're looking for CNCF projects that'll help you scale, you could use the Knative pod autoscaler, which will scale based on number of requests instead of memory compute. Or you can use KEDA, K-E-D-A, which will scale on events.
Exactly. There's different ways to do it, and it's phenomenal how far we come along in cloud.
Yeah. And Fuel Snowball's here. Hello, Fuel Snowball. Always a pleasure to see you, friend. All right. So Istio does a ton of other cool stuff too. I know it does, but I don't know what the cool stuff is yet. I'm on the edge of my seat. Uh-oh, you're silent. Right. Okay, there. Okay.
There we go. So there's something very interesting and important that must exist in a lot of environments. And it really comes down to the way we authenticate our services and authorize them. So backing up a bit, one common theme that we tend to come across is the idea of mistaken identity or someone assuming the identity of a workload. And that's problematic because if you have a misrepresented workload that enters your mesh and is able to now communicate with other workloads, exfiltrate data, that's a problem, right? So we want to be able to validate every single service that exists. So for example, if I have service A, B, and C, there should be identity attached to that. But that identity should be issued from someone that's a trusted resource or trusted entity. And that happens to be Istio as a control plane. And by the way, the control plane itself is called Istio D, which runs as a pod inside of the cluster. So
is it all one word?
Yeah, Istio D is all one word.
Istio D. Istio's control plane that runs as a pod in the cluster.
Exactly.
Is that correct?
Correct.
Okay.
It normally runs in the Istio system namespace.
Okay. So the control plane The input is what you tell it, how you want your system to look. And the output is configuration for the data plane, to configure the data
Exactly.
plane to actually move the requests around as you want.
Correct. So anything that you pass as a YAML configuration that Istio understands, Istio-D will then take that configuration and translate it necessary for Envoy's understanding, and then that becomes a configuration. And this all happens, this actual connection and translation and issuance of configuration happens through something called the XDS control plane, or XDS data plane, I should say. So that XDS data plane is the mechanism and the laneway for which Istio sends configs to Envoy.
It's like a pod running too.
No. It's part of Envoy, and it's something that Istio will speak to.
Okay.
It's not a pod or anything. It's just more of a service that pairs between Istio-D and any Envoy proxy that exists.
Okay. So XDS data plane is part of Envoy, and what's the rest of it?
And it receives through XDS configuration from Istio.
It helps Envoy receive configuration from Istio. Great. Thanks.
All right. There's a few questions that have come up.
Yeah.
So David Michael is asking, thanks for the insightful stream. Will eBPF change Istio? So eBPF in some ways has augmented and helped the performance of Istio in certain ways, but it's not going to be a replacement in any way. So I feel like we'll tangent off into this, and I feel like we have to revisit this at some point anyways. So this actually comes back to networking. Inside of a pod, right, we have a pod is what we call a networking namespace. And within that pod, it has a single TCP IP stack. So it has an IP address, and this is the way that pod can communicate with the rest of the network and other pods. But if I deploy a sidecar, I have two containers now running in that pod. And if those two containers have the same IP, how do we know to differentiate and distinguish between those two different containers? So we use port numbers. So port numbers create some distinction. So one container can call the other container on a given port through something called localhost. And so we know who we're trying to communicate with, but it'll all be contained within that same pod or network namespace. Now, anytime the main application container needs to make an external call or a call to another service, that has to flow through the sidecar proxy. In fact, it has to know how to get to the sidecar proxy, and then the sidecar proxy will then route the request to its destination. In order for that to happen, when you actually deploy Istio and you turn on something called sidecar injection, and then you deploy a new application into a namespace, a sidecar injected enabled namespace, IP tables is rewritten so that traffic now forwards through the proxy. Now, the key here is that traffic has to go from the main application to the sidecar proxy. There might be some latency in that situation. Latency means the request might be slower to respond, and that could be problematic. So the way eBPF works is that it optimizes traffic and its movement in the kernel space. So it's able to make decisions very quickly in the kernel space. And so you can use eBPF logic to optimize kernel space traffic and optimize the way the flow goes from the main app to the sidecar. So long way to say, will eBPF change Istio? Yes and no. It won't replace things that happen in Istio, but it can provide some optimizations for the way traffic moves between an application container and its sidecar.
I love it. I love that answer. And probably related to that wonderful answer, they want to know if we can definitely access the recording when this is over and watch it again. And it's going to be alive immediately on YouTube. And then one more, I'll say about eBPF2. one thing that I had to wrap my head around is when we're talking about the kernel, now we're talking about the host machine that all the pods are sitting on. So eBPF is not pod specific, it's host machine specific. That's the only thing I had to add to that. And does Istio Ingress Gateway use Gateway API? Does Istio plan on conforming to the Gateway API spec?
Yeah, actually, if you go to Istio's documentation, and as of, I think it was 1.17, the Gateway API capabilities were present. So you actually are offered the option to either use the Istio Ingress Gateway or the Gateway API spec when you're deploying Istio. It's entirely up to you. I'm just checking I'm going to check one thing on the docs just to see if it's currently in beta, which I think it is. But that shouldn't prevent you from using it if you need to, because I imagine it'll eventually move into a GA state from the Kubernetes ecosystem standpoint.
And another question, do you have a recommendation for the best way to install Istio? You can use Istio CLI or Helm or an operator.
So we're actually going to cover that. We'll cover that as we're going along. I feel like I'd be pulling away from that piece and then have to come back and revisit it. So
yeah,
we'll cover that, Akil. Don't worry. We'll
get you there. Cool. You're looking up Gateway API spec?
Yeah, but we can keep going as this is okay. I'm just literally looking for if it's how I should say beta. That's really it. Ingress Gateway, Gateway API. Oh, it doesn't look like it's V1 beta 1. So that's okay.
Nice.
And that means it's fully usable. It's not experimental or anything like that. So you're in the clear.
Cool. All right. So we're talking about, I have this. Istio does a ton of other cool stuff too, where it's some space to write down the cool things.
Yeah.
But then we started talking about some of how it works. So Istio D is Istio's control plane. It runs as a pod in the cluster. XDS data plane is part of Envoy, and it helps Envoy receive configuration from Istio.
Yeah, and I had to set that context to help us understand some of the other capabilities of Istio. So let's go back to the capabilities of Istio. We have load balancing, which we talked about already.
Okay.
And then we have service-to-service authentication.
Cool. Yeah. And why are we specifying service to service auth instead of like pod to pod or service to pod?
The primary reason behind that is because pods are immutable and ephemeral resources. So we don't want to depend directly on them as a naming convention. We rather use the service abstract to understand how to interact with them. So that's why we call it service to service authentication versus pod to pod authentication.
Cool.
And then the next one is going to be monitoring and logging. So quick sidebar, the reason why we would want to do monitoring and logging within our service mesh is really to understand the traffic path of a request. There might be multiple services that are hit in that path before a request provides a response, before we actually receive a response. Now, where the monitoring and logging come in is that if there is a failed service, we want to know about it. We want to know why it failed. We want to know how to recover from it. And so there are capabilities such as tracing that are built into the service mesh. We're able to extract logging information from a sidecar point of view. And we're able to pair with tools like Prometheus and Grafana to capture some more telemetry.
Cool. So this monitor, logging, and tracing are the three pillars of observability. So we're saying that we're talking about observability here.
Exactly.
Cool. It sounds like you went quiet. Maybe
Yeah, no, I mute every once in a while. All right. And the next feature is service resiliency.
Okay.
So service resiliency is really about tuning your microservices and the way and how quickly they respond. So if we haven't truly implemented auto scaling, we could be in a situation where one service is overloaded with a number of requests. And because of the fact that it's overloaded, that could translate to an overconsumption of CPU and memory. When it runs out of CPU and memory, what happens? It cannot do anything. It's like halted at that point until it finishes processing what it needs to. And so we have to accommodate for that level of buffering and flow control so that when we send out a request, we shouldn't expect a quick response, but if we are, we have to tune the rest of that request path accordingly. So here's a really good example. I'm a client system and I'm communicating with a web page. That web page has to go to a database to get some information to pass it back to me. Now, if I go to that web page and I say, hey, tell me how many dogs and the different types of dogs exist in this database, it has to go to the database and get that information. Now, if it goes to the database and the database itself is already processing 1,000,001 requests and it doesn't have the space or capacity to answer the web page's request, the web page has this option to wait. It could wait a bit. It could retry the request. But eventually, if it keeps retrying and it fails, it'll come back to me and say, sorry, I can't get the data for you. Now, what we could do is we could scale the database so where there are more respondents giving us that information, or we can build some resiliency into the web page to tell it to wait. We maybe assume that it takes 30 seconds for the database to come back to us. Maybe we tell it to wait 1 second, right? By telling it to wait that long, in that 31-second period, the database is going to come back and respond. But if we set it to 29 seconds, we're going to miss that window. So go ahead.
This has to do more with preventing the service from going down than bringing the service back up after it's gone down.
Partially. It also has to do with adjusting and improving upon latency as well. So we get faster responses or responses when we expect it to as well. So go ahead.
So I'm going to write faster apps that crash less often.
That too. Yeah, that's probably the best way to say it.
Cool. We have more questions.
Okay. Awesome.
Do you know if there are cloud providers that provide Prometheus and Grafana?
I'm sure all providers or cloud providers have the facility to provide a flavor of Prometheus and Grafana.
Yeah. Tiffany's here to help. She said not that she's seen by default, but here's a Helm chart to install them. Tiffany, since you're here to help, will you help with a YouTube link to this stream right now so that Indrajit can see it later? Akil has a question. So does that mean microservice A doesn't need to have the logic built in to authenticate to talk to microservice B? Can Istio handle that authentication?
Yes, Istio can be responsible for that level of authentication. And this is actually a operational challenge that Istio aims to solve. So you can actually tell your developers, hey, go ahead and build authentication into your application. But then you have to now worry about expiring authentication or expiring tokens, or you have to worry about the rotation of them. And that's not something you want to go back to your developer and say, hey, rebuild this code because now I have a new certificate for you. Yeah. So we remove that function and move it to the sidecar. That authentication is still present, but it's not on the onus of the app to do it. It's the sidecar that will be responsible for it.
Awesome. And Tiffany put that YouTube link in. So thank you so much, Tiffany, for that. Cool. And now we're ready for you to tell us more awesome things about Istio. Cool.
All right. So what do we want to cover? Oh my gosh, there's so many different things. We want to break down some of the bigger topics into smaller ones.
Yeah, are we still on? So did we cover all the other cool things that Istio does that you want to mention here?
I, you know what, we actually have, because Istio does a lot of things, but they fall into those
Hmm.
four buckets that I've just laid out.
Okay,
Yeah. And the
cool.
reason is, like, we can break down each one of these into various specific pieces. So for example, like the the service to service authentication can easily be broken down into authenticating your requests, how MTLS functions, how certificates are issued. We can even break down the service to service authorization and how Istio enforces policies. So there's like so many different ways we can break this down. I think
Uh-huh.
you tell me which one you want to pick, and we can, branch down that topic and see what we can do.
Okay. I think maybe I'd like to write, well, I want to talk about maybe how it runs. I feel like should we draw a diagram talking about
Yeah,
sidecars and the data plane and the control plane to kind of help people with that? And
yeah.
then also we have a question, which is, does Istio work with WASM modules?
WASM. Okay, so Istio actually has a custom resource to be able to create WASM plugins. There are a few features that you can take advantage of within Istio for WASM, but you're actually creating a special Envoy filter that enables a WASM virtual machine function within Envoy itself, so that you can run your WASM function. So
Cool.
you could do a number of different things with it, but quite honestly, there is so much more uh, to be discussed on WASM that I feel like we could spend, I don't know, an entire session just on it alone.
On Istio and WASM.
Yeah, exactly.
So to draw this diagram of how it works, I'm gonna make like a Kubernetes cluster, give it 2 or 3 pods, a service. What should I draw? What
So
kind? Yeah.
so we can start off with a single box that represents either a cluster or a node or a cluster
Okay.
of nodes, right? We'll just say that that's our cluster for now. And
Mm-hmm.
then at the edge, at both edges of the box, right, we can draw another smaller box or circle, and that'll represent our ingress and our egress. Okay.
Okay.
And then within the actual larger box, we can draw pods or whatever we want to draw. And then we'll draw like a little bar underneath those
Mm-hmm.
pods, and then write in traffic management, observability, and security. And right under that, we'll draw the Istio logo.
Okay. Oh, you overestimate my artistic ability. Okay, so first we're to start. This is our either this is our cluster, and it'll be a 3 node cluster, but they'll be stacked. How's that? So
That's
3 computers running our distributed Kubernetes cluster. And then we have, you want ingress and egress,
Yeah,
right?
might have to make that a little bit bigger of a box, but it's up to you.
Ingress for coming in, and then egress on this side.
Yeah, usually it's on the reverse. I don't know. It's just the order of direction, but however you want to do it.
I don't ever draw the egress. It's like it's in forever. Or egress, egress. Okay. And then we have Okay, and then we have 3 pods, and those pods are all the same, a copy of the same. Do you want the pods on the top or the bottom?
Top, please. Top.
Okay.
And give them
Oh,
a little space in between the pods.
okay. How much space? Is that enough space?
Yeah, because what we'll do is we'll just draw a little line to basically represent the portion of that box that's the sidecar as well.
Okay.
So if you
So
want to
this is running. Oh yeah.
So if you want to use a different color, and we could shade out the sidecar part. So maybe take the box and like break it in half, or however you want to do it.
I'm going to draw 2 smaller
Okay,
boxes
that works too.
representing the containers.
That works too.
So this is like an app, and I'm going to use pink for the Envoy proxy because that's the
Love
color
it.
of Envoy.
Love it. Okay. We're getting colorful in here.
Yeah.
Perfect. Okay.
So we have 3 copies of the exact same application running in each pod. And then we have our Envoy proxy.
What
Let's
about
make
hot
it
pink? In the chat.
Can we make it hotter? Then I'll put the word pod up top. And then now what do we want?
Now what we want is another box underneath those three boxes that just kind of is able to wrap them, or not wrap, I should really say, just span them, or span the three boxes.
Okay. Does
And
this
then
represent the service, the Kubernetes service?
No, this is going to represent just the Istio control plane.
Okay. Should it be further down?
Yeah, please, if we can make it further down.
Okay. And we have a lot of stuff going in this Istio control plane?
No.
Okay. This is like the win, lose, or draw portion. It's okay, now what?
Now, what we want to, are you interested in drawing the little Istio sail?
I'd have to see it. I have a hard time drawing. If I can see it, I can copy it, but if I can't see it, then
I don't know how to show you.
yeah, I don't either. I think it's
okay.
it's fine. Yeah,
That's fine. Okay.
Go ahead.
The one more thing I'm gonna probably ask you to just swap is, actually, you know what? That's fine. I guess people can get used to it. So we're gonna create some directional flow here.
Okay.
So we're gonna take an arrow and point it towards ingress.
Okay. I'm deciding color. Okay. Exactly. So we have this is an incoming request.
Exactly. It's an incoming request, right? So as it flows in, it's going to go to either one of those apps. We could pick any one. It's fine.
So it's going to go to the application container in the pod?
Yeah, but what we want to draw it as is as it flowing first to the proxy and then to the app. No, not the app.
First proxy, then app. Okay.
Yeah.
And then let's refresh on what this proxy is doing. So request goes to the proxy, and then from the proxy to the app.
Exactly. Okay. So a fun fact, the ingress that you see there and the proxy that is beside the main app, they're both Envoy.
Oh.
Yes.
Well, now it looks like I spelled ingress with like a French way, but that's
that's okay. That's okay. All right.
Cool.
So let's explain what's going on here. So as I receive traffic into my ingress or into my cluster, my ingress needs to know how to send that and where to send that off to. So it'll basically do a bunch of things, look up the Kubernetes service, and then send it off to the necessary pod. But there's a lot of stuff that has to happen in between. I think we should take this diagram and then also create a side diagram to show the flow of how all of this works. But for the purposes of everyone here, right, everyone looking at this diagram, this is a representation of how Istio would normally look, right? You would have a cluster, you'd have a control plane deployed, and then you'd have most likely an ingress and an egress gateway assigned. And the Istio control plane is responsible for programming all of those Istio artifacts.
When you say Istio artifacts, you mean all the Envoy stuff, ingress, egress, Envoy sidecars.
Exactly.
Okay. Am I using the space? Can I write that in here?
Yeah, you can write it in there too.
Okay. Istio D. Istio control plane configures ingress, egress, Envoy sidecars. Well, it's all Envoy.
Yeah. I am also going to ask you to draw three little diagrams, or three little, sorry, not diagrams, three little icons. One is going to be maybe just a 4-way arrow. You know what I mean? Like, so you've got like one arrow that goes north-south and then another one that goes east-west. And then another one that's going to be just a lock icon. And the last one is going to be a magnifying glass.
What? So just like within the cluster, all the traffic's moving with observability and with security.
Correct. Yeah.
Okay. Okay. So you you overestimate me. Yeah, all your posts about this stream is like the incredibly artistic Whitney Lee, and I'm just like,
And
okay.
I'm guaranteeing you, I couldn't even do like 1/100th of what you're doing right now. So
There's a lock.
awesome. That is fantastic. Okay. And that truly represents like the Istio architecture.
Cool.
I feel like we haven't scratched the surface yet. We still have so many things to talk about.
Okay. Cool. And then you said a side diagram. Are we gonna like zoom in on a pod and how stuff's moving in?
Yeah.
What were you thinking?
Yeah. So what I want to do is I want to zoom in to demonstrate the real flow of traffic and also talk about some other resources that influence this traffic direction. So I guess what we can start off with is an arrow, an ingress box or something, and then a box with a pod or something like that. And then we could also draw out some resources that we have to define and create for these things to function. So let's actually talk about that, because when it comes to traffic management, right, the way we move resources around in a mesh, we need one particular resource called the virtual service resource. Now, the virtual service resource is a translation and a definition of where a Kubernetes service lives, or what the Kubernetes service is. So I receive traffic on my ingress, but what is my ingress controller or gateway looking for? It's actually looking for a request on a host name. So let's say my client is making a request to www.vmware.com, right? My gateway understands www.vmware.com. And then it has to tell a virtual service, hey, I received a connection request on this host name or this domain name. Can you route this request? Okay, so you've drawn out Envoy ingress. You've got so let's draw an arrow towards it, right? And that arrow, let's just call this the Istio ingress gateway configuration.
So this is not a request.
Yeah, this is not a request. We're going to just write down Istio ingress gateway configuration. And we'll use another color to demonstrate the request.
Well, since I did request.
Oh, okay. I got you. All right, cool. Sorry about that.
No, it's cool. Oh, you're gone from my monitor. Istio. Oh, now you're back. Where am I? Okay, I'm gonna write it down here. Istio ingress gateway configuration. Cool. No, it doesn't look like a request.
Yeah, perfect. Love it. And then we can keep the green as the request.
Cool. So I like my son and I. Well, my son is 24 years old now, but when he was a kid, we used to go to a website called stuffonmycat.com. So, and all it does is generate photos of cats that have stuff sitting on them. It's still there. It's terrible. So let's use that as our example. We need to get a database, maybe call or whatever, to get the images of cats
Yeah.
with stuff on them.
Fine, works for me. But
Okay.
the host name is what we want to start off with. So let's assume
Okay.
that the domain and our host name that our request is coming in on. So that
Okay.
configuration that you drew out below is listening in for requests on that host name. So if there is a match on that host name, now that's a trigger for the ingress gateway to say, we have to route this somewhere. We have to do something with this because there's a match. In order to tell it what to do with that request, we need another configuration called the virtual service configuration. The virtual service configuration translates that host name. The website, what was it again that you suggested?
Stuffonmycat.com.
Stuffonmycat.com is translating that to a Kubernetes service.
Okay.
So the virtual service configuration is an Istio specific resource that translates a host name to a Kubernetes service.
Okay. CRVICE. So this is a custom resource, Istio custom resource that translates a host name to a Kubernetes service.
Correct.
Okay.
So once it finds that match of the Kubernetes service, by default, as long as there's no other policy applied to it, it'll forward that request to the label that matches that Kubernetes service, which happens to be the pod that you drew out.
Okay. So I'm going to S stuff on my cat. And that's what's running in here. And so it's listening for stuff on my cat. So when the stuff on my cat request it comes in.
Yeah.
We'll draw cats.
I love it. Oh my gosh.
Stuff on my cat request comes in, and Istio ingress is listening for that. And then when it sees it, because of the virtual service configuration, it knows to send the request to the Envoy proxy that's associated, that's sharing the space.
Exactly. It sends it to the Envoy proxy, which is a sidecar, and then the sidecar will forward it directly to the actual container. Ooh, Orlin has entered the chat.
Hello, Orlin. Hello. Good to see you. We're talking very deeply about stuff on my cat app. You can Google it. It's there. .com. They're gonna be like, why is this old website getting traffic all of a sudden? So the request, because of the virtual service configuration, it knows to go to the Envoy proxy. And then the Envoy proxy is configured to send the request to the stuff on my cat container that's running in this pod.
Exactly. But that flow of traffic is entirely dependent on the Istio ingress gateway configuration and the virtual services configuration. So
is this a custom resource object too, the Istio ingress gateway configuration?
Yep.
Okay.
Both of those, the one in blue and the one in pink, are both custom resources for Istio.
Cool. Great.
Okay, so that's a very introductory high level of how traffic gets in, because obviously we wouldn't want traffic just simply getting in. We want to enforce some sort of policy, and that policy needs to match on some attributes or certificates or something like that. So this is all tunable. This is all configurable within Istio. I just feel like we're running out of space on your light board here to be able to cover it all.
I want to clarify something before we move on.
Sure.
But when
Yeah.
stuff on my cat has a response now, like, okay, now I know what image of a cat with stuff on it I want to send back. That
Mhm.
goes back through the Envoy proxy,
Correct.
and then
Yeah.
that goes to the egress.
No, it'll
Then
actually.
it goes.
So interestingly enough, the ingress resource is actually receiving the request. It's not really sending out the request or responding to the request per se, but it can be tuned to do so, right?
Okay.
So the idea is the reverse path. The reverse path should be roughly the same for the request and the response itself, but that can be modified at times. It could go elsewhere. We can redirect it, but by default, yes. So
Okay.
what goes in comes back out the same way.
Okay. So now it has a cat. Just want an excuse to draw a lot of cats.
Yeah.
And now, cool. Excellent. We got it.
So another fun fact, if you deploy Kubernetes in a cloud environment, and then you decide you want to use Istio, and then you decide you're going to use the Istio Ingress Gateway, you know that service type load balancer that Kubernetes has?
Yes. Yes.
The Istio Ingress Gateway is a service of type load balancer.
Ah.
Mm-hmm. So when you landed on a public cloud provider, or you land a cluster with Kubernetes on a public cloud provider, and you deploy Istio, the Istio Ingress Gateway will actually have a public IP address. Normally speaking. I mean, in private environments, that could be a private IP. That's okay.
I'm just going to write load balance. So this traffic has observability, security, and load balancing.
Yes, because I mean, there could
Yeah.
be multiple copies of that pod as well. And the service abstraction allows us to shift it to any available resource.
And it has those, well, not on the way out, but on the way in, it would have that.
Yeah, exactly.
Cool. Excellent. I'm going to draw some boxes around what we've drawn.
Nice. Love it.
Where do you want to go from here?
Okay, so we've covered off, some of the key aspects of traffic routing. Just thinking maybe we can talk a little bit about security and understand where security plays.
Okay, let's do it.
So what we can talk about is first the concept of authentication. So normally when we have to authenticate to something, we would issue a username and password, and that's the most common approach. But it's not as if services that communicate amongst each other are always going to say, hey, take my username and verify that it's a legitimate username in your database, and then I'll also validate the password as well. It's not how things normally should work in a service-to-service environment. So the way and mechanism that is normally preferred is to use client certificates, or more specifically, transport layer certificates, or even more specifically, transport layer authentication and encryption.
Woo! Okay.
So TLS is the short form of it. But the simple idea is I'm going to make a request out to you, but you have to verify to me that you're authentic and you're legitimate and you are who you say you are. And if you are who you say you are, then the transaction can go through fine. And that's what we call one-way TLS. Now, if I communicate with the server and the server comes back to me and says, I also want to validate you to see who you are and you truly are who you say you are. Well, once you validated that, once I validated that, then we can have bidirectional communication. That bidirectional communication happens in regular Kubernetes anyways. So you have pods that will communicate bidirectionally to each other. So as a result, they should both simultaneously authenticate each other. In Istio, there's this concept called peer authentication, which enables us to determine if we have sidecar resources that can authenticate to us, right? If they have a sidecar,
Uh-huh.
have a certificate issued, and the policy says you're allowed to talk to each other, then we can authenticate each other and our communication stream can go through. But also that MTLS offers up encryption. So the traffic that's in motion between these two workloads is encrypted. The payloads are encrypted.
So the traffic between workloads adheres to policy and is encrypted.
It adheres to mutual authentication and it adheres to mutual encryption.
Okay.
Because all we're really doing right now is solving the identity piece and solving the payload encryption piece. But there's another piece of authorized, right? What services can do and what actions can they perform against other services?
Okay. So it's authenticated and encrypted and authorized.
Well, the authentication and encryption normally would happen first, and then once all of that has been resolved and taken care of, then the authorization also kicks in to just ensure that role-based access control is in effect.
And so to set this up, how much of this does the user need to maintain and think about?
So the user is going to be responsible for enabling something called peer authentication, which is a resource in Istio. And it's called peer authentication. And that simply enables the authentication as well as the encryption aspects of the service-to-service communication in security.
Cool.
And then separately, a user would have to also enable authorization so that when we make HTTP requests between services, they can only perform certain request methods, like a GET versus a delete.
And the authorization is also an Istio custom resource?
Exactly. It's what we call an authorization policy.
Cool. Awesome. So that seems, for as powerful as it is and how complex it would be to do that directly with Envoy, it seems pretty straightforward to do it using Istio custom resources.
Yeah, I mean, if you're starting off to deploy Istio, it's very straightforward to get up and running and even have all of the basics deployed. It's the tuning and the customization where it gets very interesting. Yeah. All right, so I think we've covered the necessary pieces for security. I think the last thing I want to cover off is the observability piece.
Okay. I'm going to, I think with this piece, I'm going to capture all the different Istio custom resources we've touched so far.
Yeah. Oh, yeah, for sure.
This is some of them. I'm sure it's non-exhaustive. So we talked about Istio Ingress gateway configuration. So is the gateway configuration the name of the CR?
It's called the Istio Ingress gateway CR.
Like,
yeah, it's
like, okay. Istio Ingress gateway. We talked about that one. We talked about virtual service configuration. Cool. How is the experience of being a guest on the show? Is this what you expected?
Very much so. And I'm starting to realize, like, oh my gosh, we're able to pack this light board with a ton of information, which actually is an excellent cheat sheet when you think about it.
Yeah.
For folks that just want some, hey, I want to read something in 10 minutes or less and understand, the basics of Istio, I feel like this is solid. This is perfect.
If so at the end of all of these episodes, I'll do a recap of everything you've taught.
Nice.
So I think as a consumer of video content, I might not want to watch something as long as this. Like being here live and asking questions is what is very fun. But if I was consuming it, what I would do is fast forward to the recap. I'd watch the 6 to 10 minute recap,
Yeah.
and on Twitter I have a thread of all the boards.
Yeah.
So I would get the file of the finished board, and I would watch the recap and feel like I'm going to.
Awesome.
And Orland's cheering us on. Orland says we're doing great so far.
Thank you, Orland.
Thank you. Thank you, Orland. Great.
So there's
yeah.
Sorry, there's also
Observability.
another resource that I didn't really dive too much into, but I'll talk about it now. So you
Okay.
normally would pair a virtual services configuration with a destination rule configuration, which is also another
Okay.
SDR. So
Okay.
you can think of a destination rule as a way to apply policy to when traffic arrives at the destination or how it should process that traffic towards a destination. So this is another CR. And a classic example of this is, let's say you're doing a canary rollout of a service. So you've got version 1 and you want to deploy version 2 and then start migrating services to version 2. I mean, within Kubernetes, there are ways to do this, but within Istio, you actually use a destination rule, which defines the two versions and it aligns them. Defines the two versions and aligns them to what we call subsets. These subsets are translations to version 1 of the Kubernetes service versus version 2 of the Kubernetes service. Now, interestingly enough, this is all a labeling thing. This is literally just all labels that are affixed all over. So Istio D is really just looking for the right labels on the right resource to know where to route traffic towards and how to. Another situation is, let's say you have version 1 that is not secure, not using TLS, and version 2 is using TLS. You would specify that in destination rule as well, so that we could create that distinction to know when we have authenticated requests coming in that are secure, we are redirecting to a brand new version. But if they're unsecure, they go to the old version.
So it contains your routing rules.
No, your virtual services contain your routing rules. Your destination rules contain your policy on arrival.
Okay.
And this is not to be confused with security policy. This is just more of a routing policy.
Okay. It's a custom resource that defines routing on arrival.
Yeah.
Routing policy for routing on arrival.
Exactly. I love that.
Great. Cool.
Okay, so we've got the traffic management stuff covered. We've got the security stuff covered. Let us jump into some observability. And then we can do a few things afterwards. So within observability, there really is this concept that we're trying to align to. So it comes down to latency, errors, traffic, and saturation.
Are these called the golden signals of traffic or something?
Yes, absolutely. That's exactly it. Now, Istio aims to provide these metrics on these 4 golden signals, so you can discern how services are responding, if they're responding quickly enough, if they're returning the right HTTP status codes, if they're met with some latency, if there are a set of failed requests in a given amount of time. And that's all important for building the resiliency into our microservices.
Will you state them for me again?
Yes,
Latency,
errors,
resiliency,
errors. Latency, errors, traffic, and saturation.
Yes. Cool.
Also abbreviated as LETs.
Oh, I didn't know that. So, and then Istio is. Tell me how this relates to Istio.
So this is observability, falls under one of those pillars, right? Istio provides you the facility to capture logging information, tracing information, and even metrics around latency or failed requests, or even a given amount of requests in a certain period of time. And that data that you take is allowing you to decide how you best tune your environment. But it's also telling of failures. It's telling you of any sort of scaling limitations that you're currently experiencing.
Failures, scaling, limitations.
And even tells you about any errors that you might be seeing inside of your mesh or mesh configuration as well. So it's a great mechanism to help you troubleshoot aspects of services in your mesh. Or I should really say the observability provides you that pillar, or provides you that capability.
Great to help troubleshoot, tune, debug. Get a big picture.
Exactly.
And that makes sense to me, because it's everything at every step is going through this data plane, this Envoy proxy. So if Envoy is paying attention and recording those things and maybe sending them somewhere centralized, it would make sense that such a system would allow for observability.
Exactly. I mean, the idea really is to make sure we can capture telemetry somewhere and export it to a system or solution for further analysis. And Istio, and even other service meshes too, it's not just Istio that does this, but all service meshes will capture that telemetry for short-term storage. It's not meant for long-term, but there has to be a sink somewhere where all of this can be stored and then further analyzed down the line. So it's normally a situation where you pair Istio with something like Prometheus and Grafana, in addition to tools like Kiali and Jaeger. Jaeger, and I'll describe these tools. So Grafana gives you a health perspective of all of how your services and cluster and nodes are performing, much more a metric standpoint of like CPU and memory. Prometheus kind of takes that a little bit further and gives you more specifics around those details. So you can think of Prometheus and Grafana as performance related.
I have a question.
Now, yeah.
Does this adhere to like open telemetry standards?
Yeah, actually it does. So there's, I was going to mention that as well. Now, while we do understand the performance aspect of it, we also need to understand how our services are behaving. So Jaeger, spelled, I already spelled it correctly. Okay, good. Jaeger is one of those tools that is responsible for telling us how all of our services connect. So when I make a request, it's not just one service that responds to it. In fact, if you want to draw a bunch of pods that are chained together, like maybe 5 pods that have arrows together, we could best talk about this. But in Jaeger, those 5 pods are part of what we call a request flow.
Okay.
Now, we have to know the sequence of that request flow and how these requests, or sorry, how these services are tied together. So, so it's not so much Jaeger, but there's something called B3 header propagation, or better known as X header ID, which is a unique ID that ties every single one of those hops together. So it stitches them together so we can visualize this and see this. Another way to look at this is I am curling to get a response from someone. So I'm going to curl service A. Service A is going to talk to service B. Service B is going to talk to service C. Service C is going to talk to service D before I get my response. Now, that B3 header information or that X header ID information is consistent between those four services, signifying that they're tied together for this given request. We call this a trace. And within a trace, we have several spans. Each one of those hops is considered a span.
So, what color? This is a span.
Yeah, that's a span, and the entire thing is a trace.
Cool.
And there's a question from Todd. Would you recommend tools like Zipkin? Yeah, actually, Zipkin, Jaeger, both are formats understood by Istio, so either one can be applicable to your use case. But what's also interesting is there's open telemetry support in Istio today, making it much more consumable for using OTel tools and capturing that information using the Zipkin or Jaeger formats. By the way, Zipkin or Jaeger are just formats for being able to see that trace data and span data. But the reason this information is important is if someone is trying to debug something wrong or they're trying to troubleshoot, this information is very powerful to have. So
I have another question about technology called Tempo instead of Jaeger or Zipkin.
I haven't come across a technology called Tempo. It might be less used or utilized in the industry. Have you heard of it?
No, but it leads me to a more general question: where does it work with any technology then that adheres to the open telemetry specification?
So as long as the technology or observability platform supports things like logging, can ingest Prometheus metrics, is able to capture the Zipkin or Jaeger formats of the trace data, then absolutely. I mean, in fact, a lot of observability tools effectively are responsible for this and will conform to these particular capabilities and standards.
Bucky Bucks, I don't know if it's a question or a statement, but they said
Loki and Tempo are from Grafana. Yeah. Probably, yeah. I haven't really delved too deep into other things that Grafana is offering, but I have heard of Loki. So, all right.
Further along than me. Excellent.
Yeah. All right. So we've covered the tracing aspect of it. We've covered some telemetry. There are also logs, access log data, so we can understand how services are accessed. And that all lives in Envoy as well.
So I'm reluctant to write down too much about specific things because then it seems like it's only compatible with those actual technologies when I guess I could put in etc. So so what technology did you say for logs?
Envoy just has access log output. So we're able to see what services are doing and how they're communicating and who's accessing them.
Okay. And then for metric?
And the metrics are, again, derived from Prometheus. So if you have Prometheus deployed into your environment, it'll share that telemetry data with Grafana. And then simultaneously, if you also have a tool like Kiali is a visualizer of your traffic flow. It will also provide you information on how those requests are flowing.
What was the one you said besides Jaeger? Zipkin.
Zipkin, Jaeger are formats, and then Kiali.
I'm just going to put etc.
Yeah, that's fine. That's okay.
Yeah.
I think Kiali is like a slick tool. really awesome in terms of showing y'all how the traffic is flowing, like a literal visualization of your traffic flow.
Cool.
Okay.
Excellent.
So maybe I think it'd be a good point to maybe talk about how to get up and running and installed.
Yeah. Cool. How to install Istio?
So there are a few ways to install Istio. I think the common preferred production approach would be to install it using Helm. So there are Helm charts available for using or deploying Istio, and you can customize them to your liking. And you can even use Helm to customize aspects of the Istio control plane, just to maybe do things like maybe I only want to deploy an ingress gateway and not an egress gateway, or maybe I want to turn on this ability to do DNS filtering or something like that. So I would use Helm to maybe configure it that way. I can also deploy Istio using Istio-CTL, but if you're using Istio-CTL in production, chances are you've built some additional automation around it and maybe wrapped some special processes around it. And then finally, you can also use the Istio operator, which is not really a recommended approach. It's better to use something like Helm and customize appropriately.
Okay, recommended for CID for a pipeline. Istio operator not recommended. Why is it not recommended?
There are a few reasons, and it really falls to the debate of like the community and how they view the Istio operator being more of a fixed, imperative resource, right? There are a lot of thoughts around it, and then the supportability and the customization of it. So I feel like people, or most production environments, tend to gravitate towards using Helm for consistency's sake as well.
And then do you want to talk about how Istio runs? We said it can run as a pod in Kubernetes, but do you want to talk about non-Kubernetes use case?
Yeah, so it's actually interesting. The landscape of Istio and Service Mesh kind of hinges on the fact that you're using Kubernetes, but that doesn't mean you have to continue to use Kubernetes for the rest of your workloads. It's just much more efficient to run Istio, its control plane, and some of the heavy stuff on Kubernetes. I mean, not that someone's going to stop you from deploying it on bare metal, but the idea is you use Kubernetes to handle your control plane, but your workloads, the actual workloads themselves, can be containers that live in Kubernetes. They can be bare metal. They can be virtual machines. And this is made possible through taking the sidecar itself and turning it into a binary that runs natively on an operating system. So doing the same function as a sidecar, except just running as a process now in the operating system for a non-containered workload.
So it's most efficient to run Istio in Kubernetes, but the workload itself can run anywhere.
Correct.
Cool. All right, we're running out of space. What do you want to do with this precious little bit left?
Yeah, there's a little bit here. Okay, let me think. How about we talk through the maybe a process of a deployment, a quick deployment, like kind of the key things that are needed to get a mesh up and running. So maybe we say we start off with installing a current version of Istio, and then choosing the right profile for our needs, because there are several kinds of Istio profiles.
Okay. So 1, install Istio. Okay, 2.
Oh, sorry. 1, install Istio with a profile.
2, choose a profile. That's what I was going to say.
Oh, sorry. We should probably reverse that order, because we need to specify a profile upon installation.
Okay. Tell me about examples of a profile. What's an
So
Istio profile?
there are a few kinds of profiles. There's one called the demo profile, which allows you to really just get up and running and test Istio out. And then there's a default profile, there are empty profiles, there's an ambient profile. And all of these profiles are really just tuned to deploy certain things. So the demo profile will deploy Istio-D, will deploy an ingress gateway, and then we'll also deploy an egress gateway. The ambient profile, sorry, go ahead.
So is a profile like default configuration to get started for a certain use case?
Yeah, it's different
Okay.
ways to get started with Istio.
Different configurations for getting, need to watch the edge, getting good started with Istio. So they're use case specific.
Exactly.
I can write more about profiles, or we can move on with the installation steps. What do you think?
I think let's move on with the installation steps, and I want to leave like a little bit of space for just some extra stuff that people should be aware of.
Okay. 1, choose profile.
And install. I guess that could be one.
Sure. Okay. And then what?
And then 2, we're going to label a namespace with the Istio injection label.
Okay.
And then 3, we're going to deploy our workloads into that namespace.
Cool.
4, we're going to see the sidecars come online alongside our containers. And then in brackets, you can put something like 2 out of 2. Or never mind, it's okay.
Cool. Yeah.
And then we're going to deploy our virtual service configuration and necessary ingress configurations. And then we can verify connectivity.
Cool. Awesome.
Okay.
That seems doable. Yeah.
That's doable. Perfect. Okay. I think that covers, I mean, I could go on because I was like going to go into the fact that we've got Istio CTL. We can use the CLI to run a bunch of commands. Maybe somewhere, right? Like Istio CTL is a CLI tool for managing Istio.
Istio CTL is a CLI tool for managing and interacting with Istio?
Correct.
Cool.
And then maybe we should just have a section for like fun facts or random facts.
All right. I'll just
Maybe that little middle space right there.
You're trying to cover my face, are you?
I mean, I'm trying to usually leave that little spot open for.
Kormaju's here. Hello, Kormaju. Kormaju's
Welcome.
Yeah, Kormaju comes every week. Getting here in time for the recap. It's great. We're gonna do some fun facts. I think the move is I'm just gonna stick the fun facts in and the little bits of empty space I have around, if that's cool with you, Marino.
Yeah, that's fine.
Yeah, fun facts. Let's bring them.
Okay, fun fact. Istio has a sidecarless model called ambient mesh.
Istio has a side, and we kind of touched on this at the beginning.
Right.
And it uses eBPF?
No eBPF.
No. Okay, fun fact number 1. Okay, tell me another one.
Fun fact number 2, Ambient Mesh's version of sidecar is now two sidecars. Oh, actually, let me rephrase that. Ambient Mesh shifts sidecars to zTunnel and Waypoint.
Oh, you're just, I don't know what those things are. You're opening a can of worms. zTunnel.
Okay. So, maybe let's put it this way. In Ambient Mesh, sidecar becomes zTunnel and Waypoint.
Okay.
Where would you want to put? Yeah, somewhere there.
And Ambient Mesh, sidecars. Oh, we have more buddies. Hi, Leon. Sidecars become zTunnel. Is that all one word?
Yeah, zTunnel is one word, and Waypoint is another word. Maybe, before you finish that, type in zTunnel in brackets L4.
Okay.
And then Waypoint, and in brackets L7. I'll explain that. So in Ambient Mesh, because we don't have the sidecar deployed alongside the main application container, we still need something to service that sidecar functionality. That model, we deploy something called a zTunnel and a Waypoint proxy. A zTunnel is going to be more common than a Waypoint proxy. Here's why. So in the regular Envoy sidecar proxy, it actually does L4 and L7. It handles layers of TCP requests, provides policy, and then even does things at TCP. Now in Ambient Mesh, we've split that functionality up into TCP-based functionality and UDP-based functionality, and then the layer 7 stuff. So zTunnel is layer 4, Waypoint is layer 7. Now, the reason we also did this was because to reduce the overall footprint of that zTunnel resource and only let it do things like MTLS and layer 4 policy, and even like some observability. But then if we wanted to do layer 7 authorization, any sort of fancy rate limiting, or any sort of resiliency, or even some authorization policy for like HTTP methods, that's where the Waypoint comes in on an as-needed basis. So I know we don't have much space to fit this in here, but there's one thing I want you to add is zTunnel is built in Rust and is a Rust-based proxy, or zTunnel is Rust-based proxy.
Okay.
Do we have space for other fun facts?
Maybe like up here, maybe right here. We also have a great question.
Sure. Oh, okay. Let's look at the question. If we are using any GitOps controllers like Argo CD, having a sidecar container injected to the pod by Istio will cause any issues since there is a drift in the desired configuration.
I've heard this before, like with the GitOps model, you want to define your whole system in a GitOps way. So if stuff's being injected at runtime, I've heard maybe that's not desirable.
Yeah, so I want to be clear about something. You're never going to inject a sidecar at runtime. It's actually not feasible because you actually have to break the connection for the way that container initially communicates, and then so that it can now forward through the proxy. So in the case of sidecar injection, it is intrusive in that you actually have to pause the workload and re-roll it out for the sidecar to be injected. But this is why Ambient Mesh exists. So you don't have to worry about the sidecar injection concerns and the disruption of your service. With respect to the configuration drift, if you're deploying Argo CD, and then Argo CD is responsible for actually deploying artifacts like Istio, Cilium, et cetera, to basically augment your cluster to do additional services, then it would be assumed that Argo CD would also be responsible for injecting those sidecars alongside any sort of workload that comes online, because it's an order of operation situation. You would create the namespace first, and then you would label it and then deploy your workloads. And that flow should be resemblant in Argo CD as well, or any sort of GitOps system. So there shouldn't be any sort of version drift or configuration drift. It's only if you decide I'm going to imperatively log into the cluster, create a new namespace, label it, and then deploy my workloads in it outside of what Argo would do, which is not the model you should be following, obviously, unless you're doing some sort of staging or testing. But that's where you would run into that config drift situation. Now, there's another situation, which I'll talk about, and it actually has to do with a race condition. There were situations in the past where you would have your main application container come online before your sidecar container. Why this becomes problematic is because if your main container comes online, its traffic path now is directly onto the CNI network versus going through the sidecar proxy. Now, what happens is your main app is online. It actually can't communicate on the network because you have peer authentication enabled. All other sidecar resources are expecting you to have a sidecar, but you can't flow traffic through it because your app's online, your sidecar is not. So there were two fixes for this. The first one was you could actually set a flag inside of your Istio deployment, or specifically for your sidecar deployment, to hold application until proxy starts. It's actually a field you can deploy, and you just specify a timer of however many seconds. It could be 30, it could be a minute. And this is just telling your application to not come online until your proxy's online. Kubernetes actually fixed this. They fixed this very recently, and I think 1.18, where not 1.18, what am I talking about? 1.2526?
It's like 1.18. I didn't think that was recent.
Yeah, sorry, I'm thinking Istio versions. No, Kubernetes is like 1.28 now, I think. So it was like 1.27, where they implemented the sidecar resource. So this is a Kubernetes native model or native resource that now allows Kubernetes to understand the sidecar as an init container. So when you have an init container inside of your cluster, it's responsible to finish first before any other containers come online. Cool. If you treat the sidecar as such, it's going to come online first before your main application container.
Cool. I didn't know about that.
Yes.
I love it.
Long-winded answer for Akhil's question about Argo CD, but I didn't get that.
Fuel Sonoma says the board's almost full. Looks like this stream is coming to an end. We're going to squeeze some fun facts in these little. We have like 3 little teeny spots, maybe. Yeah.
So
Marino's determined to.
The first fun fact is going to be that Istio can be deployed for multi-cluster environments.
Okay. What color? Yeah. Cool.
Another fun fact. I'm just trying to think of other fun facts around Istio. I'm trying to jog my memory. I know like a lot of things and cool things about Istio.
Yeah, it's always hard too when you're under pressure to.
No, it's just more so the pressure. It's like deciding what's the fun fact that I'd want to throw on. Okay.
Yeah.
So Istio, while it has been tuned and created for containerized workloads, there are processes available for you to onboard virtual machines into your mesh. So it goes along the line of Istio supports any kind of workload.
And can I just put Istio can support VMs?
Or you could write, you could say VMs can enter your mesh, or VMs can be a part of the mesh, or something like that.
It's better than Istio can support VMs as part of the mesh.
Okay. Whatever you feel like is appropriate. I think that works too.
All right, we have room for one more.
Let's see. Trying to think.
And similarly, if anyone has questions, any last minute questions for Marino, please ask them now. Thank you. I'm still going to go over and do a recap.
Oh,
But
how could I
yeah.
forget this one, right? Like Istio, I think we talked about it very briefly. Istio is a graduated CNCF product.
Oh,
Technology.
yes. That's pretty
That's like
new
the
too, isn't it?
yeah, it's like the biggest thing that was announced like literally in September or July. Actually, no, it was July, my bad. It was July 12th when they announced Istio's graduation into the CNCF. And something like that is actually extremely important. One, it's
Super huge deal.
yeah,
Yeah.
it's like a testament to all the work that has gone into this technology. We've effectively and in an exciting way made it boring, and for a good reason, because it means stability. It means that more and more companies and organizations are going to pour time and effort to build on top of Istio, which it's already happening. We see VMware's got Istio Service Mesh, Solo's got Glue Mesh and Glue Platform. And there are other companies that are doing things with Istio as well. Like, Google has taken Istio and put it into their, I think, GKE enterprise offering. So you're seeing how Istio is becoming very, very widespread throughout a lot of different environments. But not only that, like the fact that we've got a sidecar and sidecarless model that can operate together means endless possibilities for the variety of workloads that you have available. But dang, we actually filled the board. I still feel
Yeah,
like
we
we're missing a
did.
lot. Like I was thinking about all the Istio-CTL commands I would use in a cluster, and that's all good.
We have a comment from Avo, making room in my brain for the recap. Thanks for doing this. Thank you, Marino. Okay, let's do this. So for context, we talked about service mesh generally. A service mesh is a framework and a platform that offers security, observability, and connectivity for many types of workloads. So in the past, like before I did this series on service mesh, I totally thought it was all Kubernetes sidecars. But now it's like, well, it doesn't have to be Kubernetes and it doesn't have to be sidecars. But the consistent thing between projects does seem to be like the idea is to add security, observability, and networking or connectivity for many types of workloads. So Istio, in particular, at the time of Istio's creation, it was made because of the desire to use Envoy as a proxy. So service meshes already existed before Istio, but we wanted one that used Envoy. And Envoy is great. It's wildly powerful, but it's also wildly complex. So the idea with Istio is to simplify the process of configuring and using Envoy as the data plane. When we say control plane and data plane throughout this whole thing, control plane is what control plane inputs, the human inputs what they want their system to look like and do, and it outputs configuration for the data plane. The data plane inputs that configuration, and then it does the work of actually moving requests around the cluster and into the cluster, maybe. Moving requests around, period. So Istio then is a service mesh that uses Envoy as a proxy. That's the short answer for what Istio is. But it does so much other cool stuff too. It does load balancing. It does service-to-service authentication. It does observability stuff, monitoring, logging, and tracing. And we'll get into that a little bit. It does service resiliency, so you can tune your application so that it's faster in the first place, tune it to be faster, and also make sure it crashes less often. And we talked about a bunch of Istio custom resources, but I think I'll point at those as they come up on the rest of the board. So we talked about Istio D is Istio's control plane, and it runs as a pod in the cluster. So we drew a picture here, and so we have our Istio control plane. And then we also talked about the XDS data plane, which is part of Envoy, and it helps Envoy to receive the configuration from Istio. So we drew a picture, an image to show how it works. We have our Kubernetes cluster. It's running 3 pods. Each pod has it's 3 copies of the same application pod. So each has an application running, and it each also has a sidecar that's running the Envoy proxy is the sidecar. So a sidecar means another container in the pod with the application. It has an ingress and an egress, which, spoiler alert, are both also Envoy. So Envoy is all of these things, and then Istio exists to configure your ingress, your egress, and all of that sidecar, and all those sidecars with all of your applications and all of your pods, basically. So that can be rather a lot. So in addition to configuring Envoy and Envoy doing the work of moving all the requests around your cluster and in and out of your cluster, Istio is configuring Envoy to add observability and to add security to all those requests that are getting moved around. So we zoomed in on a particular instance to go get into it more deeply. So we have our ingress configured, our Envoy ingress and our Envoy proxy configured with Istio. And so Envoy ingress knows it's been configured with this Istio ingress gateway configuration, and it's been configured with the virtual service configuration and also a destination role configuration, all custom resources within Envoy. And so it's listening for a request. We use the website stuffonmycat.com. This is a Stuff on My Cat app, which is a real website. So it's listening for requests from stuffonmycat.com. And when it hears the request, this virtual service configuration translates the host name to a Kubernetes service. And then the destination rule also defines policy for routing the request on arrival. But basically, it's listening for requests on stuffonmycat.com. When one comes in, that means Envoy knows it needs to go to a pod that's hosting the right application, and it does the load balancing, and it sends it to the right Envoy proxy with observability, with security, with load balancing. And then the Envoy proxy will send the request through to the application. Application responds back to Envoy proxy with the photo of the cat with stuff on it. And then Envoy proxy sends that out through the ingress and back to the user. And then the user can see a cat with stuff on it, which is really important work that we're all doing here. So that's the zoomed in version of what's happening. We talked more about what it means exactly that Istio is adding security. So it's enabling MTLS, which stands for Mutual TLS, which is when everyone has a PKI, a private key infrastructure certificates, and can trust each other. And also that the traffic is encrypted that's moving around. And it enables peer authentication, which is one of our custom resources. And then we also can add an authorization policy. So then that makes sure that only certain pods, certain services are allowed to talk to each other. The ones that you say are allowed to communicate are the ones that can. So that's another custom resource within Istio. So that's how it helps with security and with policy. It also helps with observability. So we talked about the 4 golden signals, which is latency, errors, traffic, and saturation. So Istio is helping you capture your logs, metrics, and tracing for these characteristics. So that means you can troubleshoot, you can tune, you can debug, you have a big picture view of what's happening in your system. You see failures, scaling limitations, errors. So you can get all of this information from the Istio control plane, but the Istio control plane isn't meant to process that information. It's going to it's a short-term solution, and it's going to send it to some actual dedicated observability tool that you specify, whatever your observability solution is. So it has it adheres to the open telemetry standard, so it's going to work with tools that also adhere to that standard. So we talked about Prometheus. Envoy does log outputs. Metrics, we talked about Prometheus and Grafana. Tracing, we talked about Jaeger, Zipkin. But really, if it's open telemetry, the bucket of what you should be able to use should be vast. We talked about, just in tracing, we talked about the difference, what a trace is and what a span is, which is always fun. And then we got down to the nitty gritty of how to install Istio. You can do it using Helm. You can do it with the Istio CTL CLI, or you can do it with an Istio operator. You just straight up said operators not recommended. Helm's a great way to do it for production. If you need it in a pipeline situation, you might want to use the CLI. Those are both thumbs up. And then we talked about Istio profiles. So Istio, I can imagine, it sounds like Istio can do a lot of stuff in a lot of different areas. So it's probably a little bit difficult to set up. So we talked about Istio profiles, which are default configurations for getting started with Istio to help that initial. You can say what your use case is. You could, and then there might be a profile already there to help you get started for your particular use case. So for example, if your use case is just I want to play with Istio and learn it, there is a profile for that, so you don't have to install way too much, or just keep it simple. So the steps to install Istio: first, you choose a profile, then you install Istio with that profile. Next, you label a namespace with your Istio injection label. Third, you deploy workloads into that namespace. And then 4, you can see the sidecars come online with your workloads. Then you deploy virtual service configuration and any other ingress-related configurations, and then you verify your connectivity. And then you're running Istio. And then finally, in between everything, we stuck in a bunch of fun facts. So Istio has a sidecarless model called ambient mesh. In ambient mesh, the sidecars become Z-tunnel for L4 transport layer, or waypoint proxy for application layer. Z-tunnel is a Rust-based proxy. Then fun fact number 2 is Istio can be deployed for multi-cluster environments. Istio can also support VMs as part of the mesh. It doesn't have to all be sidecars or pods. Although the most efficient way to run Istio is in Kubernetes, not all of the workloads have to be Kubernetes-based workloads. Your workloads can run anywhere in VMs. They can run directly on host machines, on physical machines, on bare metal. You can run we even talked about WASM modules briefly. And so your workloads can run anywhere, but you probably want your Istio, the control plane, to be in Kubernetes. That's the efficient way to do it. And then finally, as the cherry on top, we talked about Istio's recent graduation. Istio is now a graduated CNCF project. Ooh, ooh. Yeah, so that's the end, except that we have a question. But before we get into the question, is there anything else that I didn't say that you would like to add, Marino?
Oh, I feel like you just taught everyone Istio in like 15 minutes. I love it.
15 minutes and 2 hours. Yeah.
you covered a ton in this little 2-hour window. So I'm just like surprised. I feel like anyone that's trying to get a good sense of how Istio works, I mean, you're never going to be an expert just by looking at our video here. You're definitely going to have to try and mess around and fail a few times, but it's a great starting point. I feel like you covered all the necessary essentials to get folks acclimated with why use a mesh, and then get them ready to just jump in and test this out with like kind. So
yeah.
Love it. 100%.
Love it. Let's do it. Then let's get to this question. What's the difference between the Istio control plane and the Kubernetes control plane? Would you like to get that?
Yeah, so the Kubernetes control plane is responsible for driving orchestration and scheduling operations for workloads that exist inside of your cluster, that exist inside of your Kubernetes cluster. It's also responsible for node-to-node connections, communications, health, and whatnot, just so that you can operate the cluster, and then processing any additional configurations you pass to it. The Istio control plane doesn't drive Kubernetes operations. With the exception of one resource, and I'll talk about that in a second. The Istio control plane is there to drive configuration and automation, and even just management of Istio-specific resources that reside on top of Kubernetes. So even though you've deployed Istio to support mesh-like functionality, Kubernetes is still responsible for the reconciliation. It's still responsible for scheduling a workload on a node. It's still responsible for all the regular things Kubernetes would do. So they're basically separate entities that operate in the way they should. Now, I mentioned that Istio drives one Kubernetes component. So there's something called the mutating admission webhook controller in Kubernetes. And that webhook controller allows you to mutate resources inside of Kubernetes. And what I mean by mutate, modify them. You might want to modify a resource for changing its name, although you wouldn't really do that. But you may want to modify a resource to inject a sidecar. So the sidecar injection functionality is made possible by the fact that the mutating admission webhook controller allows you to modify a deployment resource to add two fields. One container, that's the init container to redirect the networking, and then the second container, which is the sidecar, and then your third container just shows up as a main application container. But that's the only other thing that Istio drives from a control plane standpoint that is specific to Kubernetes. Hope that answers your question, Indrajit.
Yeah. So the Istio control plane inputs human, like really your desired configuration in the form of these custom resources, and it outputs configuration for Envoy, for this Envoy data plane. And then Envoy takes that configuration and actually does the work of routing requests. So the Kubernetes control plane controls all the Kubernetes specific resources.
Exactly.
Cool. So I don't know if you've watched an episode all the way to the bitter end before, but what we do at this point is we dance our goodbyes. I'm going to replay the intro music and we're going to dance and say goodbye to everyone.
All right.
How's that sound?
That sounds good. I'll try to dance to that. Thank you so much, everyone, for coming.
Thank you, Marino, for sharing your expertise and your time with us today. I appreciate it very, very much.
I appreciate it as well for you having me on. I mean, it's like I said, I've been like waiting for that moment. You finally did it.
I hope it lived up to your expectations. And thanks everyone for joining in the amazing, amazing chats. And thank you for those who watched the recording. Bye. Yeah. Nice.
I don't know. You'll never find me at a club because I never. I can't do the weight.
It's on the hands. Awesome. Yeah. Look at that. Heck yeah.
Oh my gosh.
Bye,
It's so embarrassing. Yeah. Take care, everyone.